Hi, this presentation is a continuation of the previous videos, little instructional videos on Seisnetics. We're just going to cover some of the basics. We're going to open Seisnetics volume. This particular one is from Chandon, from the Northwest Shelf of Western Australia. We're going to highlight some of the inline, showing how we can, one of the ways in which we can select the line and adjust the color palette. And we do the same thing for the cross line, adjusting where we want to go into the data. And we can highlight the change the color palette. We like to use a grayscale because of course all the surfaces have different colors, and if we use different color palettes, some of those colors might get lost. Here we're turning on one of the well locations. If you have time index logs, you can load that as well. Now we're going to open up the trough populations from this particular open file data volume. Now these surfaces have been picked via genetic segmentation, and what we're going to do is grow populations based on the genetic and spatial compatibility of particular waveforms, and we create a catalog or a database of all of these surfaces, which you can see here in the upper right hand corner. They all have an ID, they all have a count, which is the number of individuals in the population, and we can view each of those surfaces either the polychrome or monochrome or polychrome. Here we're displaying the fitness attribute, which gives you the genetic relationship between the common waveform shown right in the lower left-hand corner and every individual in that population. The light green color gives you an indication of genetic relationship between all of them, shows you high degree of genetic compatibility, where it's dark blue and dark green, it may be a first or second cousin, just showing you that there's areas of changing reflector geometry in the data set. Now what we're going to do is we're going to highlight all the populations that were identified in this process, and we're doing that at the moment, which is thousands. And what we're doing here is we're going to go through and we're going to adjust the opacity so that we're only looking at the surfaces, and we've turned the seismic off. And what this allows us to do is review and draws our attention to changing or abnormal reflector geometries, but also we see negative space in these dark spaces where populations have failed to grow. And this might be an area in this particular data set of a mass transport system, or it might be associated with near a fault, or it might be a depositional sequence that large populations have not formed just because the energy, the high energy of that particular depositional environment.